Okay, so don't write this down. This is just, this little outline was what we had up the last time we talked about section 2.3. And today we're just covering the last two little parts here. We covered the first three in part one. So we're going to look at function notation, and we're going to look at this idea of functions increasing, decreasing, or staying constant. So that's the goal. Let's just jump right in here. Function notation. You might want to write this down. So let's make sure we know what this means. Math is a real compact language, but it is a foreign language. What does this mean? Well, if you go back, when we started talking about functions the last time, that right there is our magic box, right? And so we're going to send one value into it. We're going to get one value back. So this notation right here doesn't mean multiply. It says, if y is really a function of x, then you send me an x, I'll send you a y based on that function. That's all that's saying. Now, it has to be a function to start with. In terms that we use every day, we just say, that's telling you what to plug in for x. It's saying, when x is this value right here, what's y going to be? So it's like making a table almost. So my little example down here says, if I send it a 4, so if I send 4 into this, what am I going to get back? A 7. It's a function. One input, one output. Now, in some forms of math and in computer science, you can have functions that there's more than one input coming in at the same time. But you're still just going to get one output. So you could have functions of more than one variable. It's kind of weird. We're not going to worry about that. We're just worried about functions of one variable here. All right, let's take a look. If you'll copy this down, let's work a few examples here. And these are like the homework are going to be. We have two functions here, f and g. Both of them are functions of x. And so the example 1 says, basically, that's shorthand for evaluate function f when x is 2. So where x is 2, I'm just going to, every place there's an x in my original function, I'm going to put a 2. Notice the negative sign goes outside the parentheses there. Okay, I'm just plugging the 2 in. It says evaluate this function. In other words, give me a y when x is 2. So I've got minus 4, minus 12, plus 4. That's what I'm getting. Not too bad. Example 2 says evaluate f when x is m. Now, m is just some number. So let's do that. So I just plug an m in place of x. So I've got minus m squared minus 6m plus 4. And that's as far as we can get. Now, if somewhere down the line somebody said, well, let's let m be 2, then I'd have the same thing as I got in example 1, right? But now this is as far as we can go, because I don't know what m is standing for. Let's look at function g down here. So I'm going to say 3 times a plus 1, because that's what I'm substituting in for x, plus 1. So I'm getting 3a when I distribute that 3. Check my math. And so then if later somebody said, well, let's let a be 10. Well, I would know then that I would get 34. So if a were 10, I'd get 34 for my y, or whatever that dependent variable is. Stop right there. Question about any of that? They're going to ask you problems like this on the homework. That's why I bring it up. Now, don't write anything down yet. Just think with me here. There are 4 different ways they could ask you to do this, though. Look at A. That's what we just got through doing. In other words, they're going to give you the function expression, and then you just plug in the value for x. They could give you ordered pairs, like in B. They could give you a map, like in C. And they could give you a graph, like in D. And they could say, evaluate this function when x is da-da-da. So they want us to evaluate these things when x is 3 for all of them. So on the first one, that's just what we've been doing. So this is going to be 3 times 3. I'm evaluating it when x is 3, minus 7, 2. So for A, f of 3 is 2. In other words, when x is 3, y is 2. Look at B. Don't let this throw you. They're saying when x is 3, what's y? 1. So here, f of 3, you can just look at it and tell. Same way down here with the map in C. Look at your domain. That's where your x's reside. The domain, where is x? 3? Well, right here. What's the y? 5. So f of 3 on this one is 5. That's the kind you hope you get on a test. Get crayons out and color them in. Just have fun with it. Look at the graph. When x is 3, which is right here, what's y? So on this one, there's 4 ways they could ask you to evaluate a function. And each one of those is in the homework. And these are going to be online, so you don't have to copy all of this stuff down if you want to later on. I want you to have some time to work some problems. Now this is saying rewrite these using function notation. So that's part 1. And then part 2 says find f of -5 and f of t. So I'll give you a second to copy these down. So example 5, first thing we're going to do. Now look what it's saying. It's saying y equals x squared plus 1. But y is a function of x. So to write it in function notation, I'm just going to say, okay, f of x, in other words, the y, equals x squared plus 1. Nothing really to do there, except the notation. And then we want to find f of -5. Okay, so every place I'm seeing an x, I'm going to put -5. So I've got -5 squared. And here, the negative sign does go inside the parentheses because we're talking about -5 plus 1. Okay, -5 times -5 is 25 plus 1, 26. Then f of t every place there's an x, I'm going to put a t. So I've got t squared plus 1. Well, that was pretty tough. If somewhere down the line they said, let's let t be some value, like, I don't know, -6, then that would evaluate to 37. But right now, that's as far as we can go. Example 6 is more interesting because look at the difference in it and what example 5 had. Example 5 already had solved for y. Example 6, we have to solve for y first. So do you want to take the y's, you want to leave them on the left-hand side or take them to the right-hand side? Okay, so I've got 2x equals 6 plus 3y. I want to isolate the y. So then I'm going to subtract 6 from both sides. And then I'm going to divide by 3. Now I could mess around with that and get a slightly different form, but that's my function there. So now to write that in function notation, I can say f of x equals 2x minus 6 over 3. To find f of -5, I've got 2 times -5 minus 6 over 3. So -10 minus 6. Check my math. If we're good, that's how that would evaluate. F of t, I've got 2t minus 6 over 3, and I'm done. Okay, don't let example 7 throw you. Every place I see an x, I'm going to put minus x. So I've got minus 4 minus x plus 2. Well, minus 4 times minus x is 4x. There's my answer. It's a real mechanical kind of thing. Just take whatever point they're saying to evaluate this and just plug it in. And those can get complex sometimes. Then on example 8, what am I going to do? I'm going to say minus, no. I'm going to say minus a half squared. The negative sign does not go with the 1/2, notice. Plus 7 times a half minus 5. All right, I know 1/2 times 1/2 is 1/4, so I've got minus a 1/4. 7 times a half, just multiply that whole number times the numerator. Because really this is 7 over 1, right? So it'd be 7 times 1, 1 times 2. Minus 5 over 1. What's a good common denominator? 4. So I've got to check each one of those denominators and say, what do I need to multiply by to make that a 4 on the bottom? Well, first one I don't need to multiply by anything. So it's just minus 1. This one I got to multiply by 2. So I've got plus 14. This one I've got to multiply by 4. So 4 times 5 is 20. All of that's over 4. Again, double check me. All right, so I've got minus 1 minus 20, so there's minus 21 plus 14 is minus 7 over 4. So I think that's what it would evaluate to right there. And the reason I picked that problem is when I opened up the textbook to see what kind of problems they were going to give you, that was an actual problem. So I wanted you to see it. Now the numbers might change some, but be looking for that one. All right, don't write all this stuff down. The notes are going to be online. But just read it. Just read that note up there. What's the important stuff? This. What does y do as x goes from left to right? That's the big deal. As x is moving from little to big, what's happening to the y's? And it's all about an interval. This is interval notation that we're talking about. All right, so look at our drawing, the blue part. Where's this graph starting? At what x value is this graph starting? The leftmost. -2. And if you look at the blue part, as x moves from -2 to 1, the y's are always getting bigger. Remember, what does y do as x goes from left to right? Well, as x is going from left, which is -2, to right, which is 1, the y's are getting bigger. So in interval notation, I would write from -2 to 1. Now notice that's an open interval. You got to read the question. If they say open interval, then you're going to use parentheses. If they say closed interval, you're going to use brackets. Got to read the question. But when x is in between here, then the y's are increasing. Okay, decreasing. What do you think?
4, 6.
Okay, in this interval right here, the y's are always getting smaller, always getting smaller. So I'd say exactly what the lady said, from 4 to 6, decreasing. And then where do the y's stay constant? Well, from 1 to 4. That's about as hard as it gets. Now, this could be a curved graph. It could be like x squared, where it's like this. In which case, it's never constant, right? Never constant. It's either decreasing or increasing. It could be a graph like this, where they're just talking about that horizontal line. It's always constant. So let's look at one more example here. Those of you that have seen my drawings before realize this is one of the better ones. If you'll jot this down real quick. These arrowheads here mean what? Does not end. Thank you. So, increasing. Start as far left as the graph is indicating. Where's that? Good. Negative infinity. So, as x is moving from negative infinity up to negative 1, it looks like the y's are increasing. Decreasing. Well, as x goes from negative 1 to positive a half, the function, that is the y's, are decreasing. And then constant, looks like it starts at a half. And again, the arrowhead says keep going forever, so to positive infinity. There's several homework problems just like that.